Do you have a passion for rotorcraft? How about gyroplanes? In this week's episode, we traveled out to Zephyr Hills, Florida to get a factory tour at Silverlight Aviation, makers of the American Ranger gyroplane. I've always been fascinated by how things are manufactured and assembled, the fine details and engineering processes that make raw materials into great products, especially products that fly. The gyroplane is an interesting combination that I know very little about. So let's learn something new today together.
Okay, so this is basically the overview of the shop, assembly shop. This is the floor and the hangar. And you can see all the gyroplanes, 4 or 5 gyroplanes standing around. You might see a plane over there, composite plane over there. That's a secret project, should not be talked about. But yeah, Composite Shop is basically hidden on the side, and essentially this is what the shop looks like if you're looking at assembly. So when the customers come over for Builder Assist, they're working usually in one of those stations. My name is Abid Faruqi at Silverlight Aviation. We manufacture US-made gyroplanes right here in Florida, near Tampa, Florida, Zephyr Hills, Florida. We have model with the canopy enclosed, which is AR1C, so it's kind of a convertible. C stands for convertible. You can go from one of these to one of those in the same aircraft in about 30-35 minutes. So we did that. So there's the AR1C configuration and then just the regular AR1 configuration, which is basically with just the windshields, fly like a motorcycle out the sky. So that's what we do here. And this is our assembly line. So we provide builder's assist for our customers. They usually come in for about 2 weeks or so, usually take training and stuff during mornings and evenings and do the build. Generally 2 weeks is enough to get them the 51% on the FAA checklist. That doesn't mean the whole aircraft is finished, especially if it's canopy, because we actually fit, there's a lot of handwork on canopy, fit and finish. And then they will assemble it, then we actually take the body and everything off, send it to paint, and then do the final assembly. The machine starts with a frame. That's where people will start, is something very similar to what you're seeing here. This is a freshly welded frame right out of our welding shop, which is just right down the street. And it'll come like this, and this is where you will start your assembly. So right now you can see the landing gear, which we also make ourselves. It's a 7075 T6 leaf spring. That's put on, then we will have wheels and brakes, and then the front fork gets put on, front fork assembly. So what people will be doing is they will coming in around this point and taking it from there all the way. You can see something that's being worked on for a customer right there. Now that one right there is actually going to Taiwan, so we are just building it for them. This is our welding shop, fabrication and welding. All the metal fabrication and welding happens in this shop. And we start with basically raw materials right here, stainless steel mainly, because our frame is all stainless steel for the most part. We start with that. We actually, if you see, we are processing a batch of 3 right now. We will take, there's a special process definition that's written down, documented, that he will cut certain lengths of tubing. They'll actually weld it shut on one end, pack it with moist sand, compact the sand inside, then weld shut on the other end, and then he has to mark certain measurements and stuff, and we actually do this pneumatic bending right here. And the reason for packing it with the moist sand is that these collapsings right here to control that, so it doesn't collapse more than what it is. This is a very thin wall tubing, so if you didn't do the sand in there, it will collapse like quadruple this. Basically, we will bend all the tubes that we need to bend, and each frame, as you can see, requires about 3 tubes that have to be bent. So this is the longest one, which is the lower keel tube right here. And then we have the upper keel right there. There you can see one of them is sitting right there, already done. Okay. And then the third bend that we do is on the mast, which is this tube right there, and then a backup on the mast. So those are the 4 tubes that make up essentially in the frame. So we start with those tubes, and we'll do like 3 or 4 batches at a time. We control the material. We buy it from a mill in the US specifically. We order it, so we're always getting the consistent US made stainless steel for our main frame. There are some small tubings that are probably Taiwan or Chinese. We don't care about them, but the main structure is always US made stainless steel.
And how do you accomplish your jigging? Do you have fixtures, or do you have
so
pre-drilled holes into it? Or?
Exactly. So if you look at this table right here, you will see these different cutouts that are laser cut, very accurate. So you can see right there, those cutouts actually are, we use clamps on them, but those cutouts are actually ones that actually define our fixing of, for example, the mast, right? And the fixing of like the upper keel tube and stuff. So we will do the mast assembly separately, and we will use some of these cutouts. These cutouts allow us to jig it up properly and clamp it properly, and then after it's done, for example, the mast assembly, it will completely come off and go on the lower keel and upper keel. Okay, so you saw the frame. So what we do is from that point forward, we start working with the customers. Generally, we'll assemble all, this is the control tubes right here, scissor tubes they're called sometimes. Stick assembly, front fork is installed right here. There's a whole sub-assembly for front fork that they do. We have exploded view diagrams for anything, so as long as you can read those, you have some mechanical ability, which is assumed, you'll be able to assemble all those. We use AN hardware. There is no metric, no industrial hardware anywhere, except for things that are just like holding the body up. Those are SAE hardware, industrial, because it's stainless steel. But anything that's structural is all going to be basically AN hardware for the most part. So the hardware can be gotten from aircraft spruce, from Airfasco. We buy a lot of our hardware from Airfasco, which is a manufacturer of AN hardware in Ohio. Some hardware from aircraft spruce as well. So we know we get genuine aircraft AN hardware, not copies. So we do all of that right here. The customer will be building, this is the fuel tanks right here. We weld our fuel tanks out of aluminum. Has worked very well for us. We have seen a few crashes, and so far it's been held up very, very well. And the main thing is it can handle any kind of gas. So there is no problem with ethanol, no problem with even if the formulations change in the future, as long as it doesn't eat metal, the aluminum fuel tanks are very well. So this is like 060 aluminum 5000 series aluminum TIG welded, and we leak tested 3 times before it leaves our shop here. The wiring harness is then put on, the controls are put on, which are throttle, and these circuits are done. Wiring harness is put on. You can see that the rudder cables are still not done completely. So this is for the rudder cables right here. This is the back. So you see this, he's leveling these together, so making sure they're in the same place before he does that. So and then he's going to Nico press and swage this Nico press coupling right here. And all of that is done. Then the body gets put on, but before the body gets put on, actually what happens, if you look back here, is the engine gets put on. Now there's a few things we do to prepare the engine. 912 ULS, we have to actually change the water pump housing that's coming out, the water pump fitment that's coming out. We actually make our own because we want to route behind the water pump in a certain way. In a 914 it works this way. All of us, we use the Rotax engine mount, the ring mount. We use that. And then this is the pre-rotation system that we put on the engine right here. So these parts right here, this is a swing arm that tightens this belt up. That's for pre-rotation. So we are installing all of this. Is the pulley and a spacer for the propeller we use. And so this arm will get squeezed in the front by a bicycle-like handle, and it tightens this up. That drives this pulley that drives the horizontal shaft into a universal coupling into a 90-degree gearbox, and that turns it up here, and this turns and it's going into the Bendex up there. If you see the golden thing, that's the Bendex. And the Bendex will pop up like your starter, for your car. When it starts to turn, it will pop up and engage that ring gear, that's the big ring gear that's up there. When it engages that, it starts to pre-rotate the whole system of the rotor.
We are partnering with great companies like Dynon Avionics at Dynon.com, Airtech Coatings at AirtechCoatings.com, AviNation Youth Magazine at AviNationUSA.com, the Aviators Clinic at AviatorsClinic.com. Take a moment to go visit their websites at the links found below in the description of this video. And visit our website at ExperimentalAircraftChannel.com for events, our video library arranged in easy-to-find playlists on specific topics, affiliate products, aviation merchandise, and so much more.
So our composite shop, so we do all our own composite work. What you're seeing here is the layup room where we actually do all the layup. So as you can see, this is a tail, the top half of the tail and the bottom half of the tail. It's been all put together, and now we are going to be gluing these two halves together with structural glue. That's what's going to be done, but you can see the mold for the tail is sitting here. So basically, we only bring in those molds in here which are being used at the time, because the molds are big. We don't put our molds outside. So the molds have to be, usually the area for the molds are staying outside unless it's being utilized. So this is mainly the area where the workers will be actually laying up the fiberglass. So fiberglass, we use mil-spec cloth, woven cloth for fiberglass called 7781. We also use 3K twill carbon fiber as well, as you see right there. So depending on part and depending on options the customer has selected, we will do fiberglass or we will do carbon fiber, either one. And so yeah, this is all the layup room. So you can see the carbon fiber, half of the body is sitting here. So it will be trimmed, and after trimming and everything, the second half will be trimmed, and then they will actually combine them together, put the mold together, and glue in the middle. So there's a seam in the middle that gets filled up. So this is basically our composite room. We do all our composite work ourselves in-house, and there's storage upstairs. After the things are done and they have to be QA'd, they go upstairs, then somebody goes upstairs and checks them out before putting it out in production. But basically, if you bought a kit and you wanted to build it at home, you will get something that looks like this. And you will have to do the body work at the seams. You will have to do, you'll have to do all the little pinholes that you always find in fiberglass, and all of that is going to be done. And that's what you will end up with if you were doing it completely at home. So right here is our basically avionics electronic room. So this is like something being fixed for some customer, but you can see we do our wiring harnesses. Many of them are done in advance. So this is a 915 IS back half of the wiring harness. We divide the wiring harness into like two sections. One is kind of like right in front of the front seat, and it goes into the panel like that, like this. So you'll have this guy, and this is not finished yet. And then you'll have the back half that we can do ahead of time. So we have 914, 912, 915 wiring harnesses. They are already done and they are set up for certain instruments. So you can either buy the instrument panel just uncut and do your own. In that case, you will have to do the front half of the wiring harness yourself, or you can have us do it, and then all you're doing is installing the wiring harness, which still takes some skill and knowledge. But we have a lot of notes. Some customers who come here for Builder Assist want to participate in the wiring, and some don't. Some would rather have us do all the wiring and not bother with the wiring. Okay, so we will go up towards the parts room so you can kind of look down. And This is Dan right there. He's my friend and engineer who works with us, does all the SolidWorks modeling.
He's a silhouette.
He's a silhouette, yeah.
Really?
Okay, so this is basically our small parts room. All the CNC parts, all these CNC parts that we basically serialize or assign batch lot numbers, so we know if you have a part that's defective, which lot it came out of, etc. All these like brake rotors we make ourselves, and they are all cadmium plated and stuff. All these CNC and this plating and stuff we do locally as well in the United States, but it's not done, we don't do it. There's plenty of CNC shops around that are good, and we use them. But we do receiving inspections, but we do all of this 6061 T6 mainly machine parts. These are some of the welded assemblies. So a lot of the parts will be cut by a laser at a local laser shop. They will cut all of this and then we put it together and make like assembly. Then this gets QA'd and it gets put here. There are some assemblies that are pre-done, for example, like the nose fork. Now this is a full assembly with the explorer view diagram of its own, and this is done as a pretty beefy nose wheel assembly, as you can see. So those things are done and put up here. You can see some of the nose wheel even with tires already done sitting there. Those big tires we are just starting to offer that as an option. So we are actually in the middle of prototyping the turf glide tires on the main wheels for better grass field operations. If you're mainly operating out of grass, that would be a soft field operation, because you can run it at 10 to 12 psi. So engine options. We mainly have designed the gyroplane around the Rotax ASTM compliant engines. So our base model is Rotax 912 ULS, 100 horsepower, normally aspirated, no turbocharge. Then we have the Rotax 914 UL right here, which has a turbocharger, 115 horsepower. And last one, like you see on those two red ones, it has the Rotax 915 IS, fuel injected, redundant FADAC engine from Rotax that is 141 horsepower, a lot of horsepower for this gyroplane. And those are the standard engines. We have done one engine which was the Edge Performance conversion of the Rotax 912 ULS, 150 horsepower. There is one out there that's flying that way, but generally we support all the Rotax line of light sport engines, 4-stroke aircraft engines. So this is our gyroplane. This is the one with the AR1C with the canopy on. So how do you operate one of these? Basically, let's say that this is locked, and you can hear that lock very, very clearly. You're going to take your hand and you're just going to move it down, and that opens the lock, and you go up like that. And basically to get in, stick all the way to the right, left foot right here, and then you can take your hands and balance yourself right in the middle of the seat. Get up there. No problem standing on the floor, and essentially this is how I sit down. Seat belts, could be put on if I wanted to, but I'm not going to do that right now. But here it is, and so the cockpit is arranged so everything is kind of in front of you. There's only one thing that's not in front of you, and that's your comm jack. So comm jack for the 915 is right here, whereas the comm jack for the 912 and the 914 is underneath the seat. And we kept the comm jack away from here because we didn't want a wire kind of going from your headset into the instrument panel. Startup procedure would be master on, okay, lane A, lane B on in this case. I'm not going to actually do a startup, but fuel pump 1 on, EFIS on, which will turn on your EMS, the engine monitoring system. And of course you need that because as soon as you start up, you want to make sure there's oil pressure. If you didn't do that, you would not have oil pressure. You can shut the LCD, this is the iFly GPS, we do that as a standard option, but I'm just going to turn it off because we don't need it right now. I'm going to take the Avionics, which is transponder, intercom and radio, as well as ADSB. That's all on the Avionics submaster, and we're going to keep that off. Lane A and lane B are turned on, but they're not getting any power right now. That's why all these X's. So as soon, now I'm not going to do it, but as soon as I put power on this way, you will hear the end, fuel pump 1 will start to go, and you will see these things, X's disappear. So, and I let the fuel pressure build up till it says 30 or 32. Before I would, while holding this, I would push this button to start up. Of course, I'm not going to do it here. People always ask me, like, you get this thing going before taking off. We call that pre-rotation. So gyroplanes, most of the modern gyroplanes have pretty powerful pre-rotators. In the olden days, you used to be able to get 100, and that was lucky. 100, 120. Maybe some of the, then they started developing better, and now pretty much everybody has a pre-rotator that can get to 150 to 250, almost 300 even. So the pre-rotator is done, in our case, by keeping the stick forward. And if you notice this bicycle handle right here, so if I squeeze this bicycle handle, you'll see at the back there is an arm that gets depressed, and that tightens the belt, and it actually starts to pre-rotate right here. So while pre-rotating, I am going to take my left hand, and the brake is right here, and I call this the taco. I will taco my hand and hold the brake, and I'm going to control the engine RPM by moving my taco front and back. So I'm holding the brake the whole time. It takes a minute for pre-rotation. So I will squeeze this, and then I'm slowly increasing engine RPM, watching the rotor RPM that is right next to engine RPM right here. See, engine RPM, rotor RPM. As the rotor RPM stops increasing, I'm going to increase the engine power just a tad, like 200 engine RPM at a time. Let the rotor RPM catch up, get the torque transfer happen. Once it stops increasing, I'm going to go more, a little bit, 200 RPM at a time, a little more, till I see the rotor RPM come up to 180 to 220. And at that point, I will let go of the pre-rotator, pull the stick back, let go of the brake, and then I'm just using the throttle to advance the throttle and move forward. The VSpeeds for takeoff, you will break ground at about 37 to 40 knots, depending on if you're doing a soft field technique or a normal technique. So 36 to 37 knots, a soft field technique, you can break ground. Then you get in ground effect, build the speed up generally around 50 knots if you're doing VX, 48 knots. You can climb at 48 knots for VX, which is your best angle of climb if you're trying to clear a 50-foot obstacle. Or you go to 53, 54 knots. I usually use 55 because it's easier. And that's my VY, basically best rate of climb speed. So those are the speeds we'll climb at. In the pattern, you could be operating anywhere between 50 to 65 knots. That's generally the pattern speed. My final approach is usually around 55 to 60 knots. The glide ratio in the gyroplane is a great 3 to 1, 3.5 to 1 maximum. It's not a lot. It's a rotorcraft, but it can also land on a postage stamp. So price points and different model and configurations. So we start at the base model, which is basically your basic open cockpit, like semi-enclosed cockpit like this, windshields, motorcycle of the sky type of deal, AR1 with 912 ULS engine and basic day VFR instruments. A whole kit, including the engine, including everything that you will need to finish it, you can get in about, I would say about $65,000. Okay, if you want to build it yourself. The builder assist will add about $5,000 to $6,000 to that. Because if you want us to test fly it, we can do it for you for an additional fee. But basically, that's where the kit starts, a full kit, something that gives you everything that you can go from starting to finishing it. And that's with a painted body. If you wanted to paint yourself, it's about $4,000 off. If people were going to do their own builder assist and they want us to ship the kit, which is not what most people do, they take the builder assist and come here and do it with us. They can do that. It's possible to do it. We have exploded view diagrams for every subassembly, and we are available with email support for anybody with pictures and stuff. We can guide them through it. That includes the wiring, basic wiring harness and basic instruments as well. If you wanted to do all your instrumentation, you wanted to have your own engine, you want to do all of that yourself, painting and everything, you can get a kit at about $48,000, $49,000. And then you have to buy the engine, propeller, you know, all that stuff you want to do if you want to do it on your own. Some people have used engines. If they have that, they're welcome to bring that engine. We don't stop them from doing that. Even with builder assist, if they want to come here and ship their own engine, we are okay with that. People can find all this information and contact us via our website, www.silverlightaviation.com. That's Silverlight, SILVERLIGHT, aviation.com. And yeah, there's a contact us form. They can ask us for quotes specifically, ask us if they want to hear about training and stuff. We do hook them up with different instructors for training. So, but yeah, all that stuff is there.
And if you really want to have an engineering lesson on how exactly a rotor creates lift and dissymmetry of lift, check the link above or the description below for that video.